Hi everyone, my name is Tolga Tarhan. I'm the CTO of Onica, here today to talk about Windows workloads on AWS. Before we get started, just a quick overview of Onica. Onica is a premier consulting partner for Amazon. Workloads from migrations to DevOps to big data to net new application development in the cloud and IoT software and hardware. We've been doing this for a number of years and are one of the fastest growing partners. Amazon does measure partners by competency, and one of the competencies is around Microsoft workloads. And so specifically, we've got competencies around application modernization and Windows workloads, as well as SQL Server. So with that out of the way, we're going to focus today on Windows workloads on AWS, starting by just dispelling a couple of myths, then going on to why you would pick AWS for Windows workloads, presenting some options, deployment options, and development options for Windows and .NET workloads on AWS, and then talk through a use case. And then finally at the end, we're going to talk about how you'd modernize .NET apps to actually become cloud native, which would be the next step of an evolution for those apps. So first, the myths. These are the three. We hear them a lot. So there's a perception that because .NET and Visual Studio are Microsoft products, they must be better on Microsoft's cloud. The next one is that if you switch to AWS, you can't keep the tools and tool chains you're familiar with. And the third one is that you can't use those tools to manage infrastructure. So it turns out all three of these are actually not false. I'm going to hopefully convince you through this presentation that in fact AWS is the best place to run your Microsoft workloads, that you can keep your tools, and that in fact the infrastructure management of AWS will integrate with those tools perfectly fine. So let's start with why we would select AWS. So you may already know this, but AWS is organized regionally with 19 regions, a region being sort of an isolated, self-contained deployment of AWS. So a failure in one region is not expected to propagate to other regions, allowing you to build complex sort of DR scenarios. Within those regions, there's a total of 54 availability zones, which is isolated failure planes. In other words, different buildings with different air conditioning and different power. And so they're in the same region, but they're physically isolated, enabling us to build HA solutions. So where we'd use regions for DR and geographic distribution, we use availability zones to build highly available applications. And then layered on top of that, there's 103 edge locations. And these edge locations are points of presence for CloudFront primarily, enabling caching and distribution of content closer to your end users. Now, kind of turning the page and looking at Windows in particular, from 2008 to today, you can see the rate at which adoption of Windows workloads on AWS has grown. We are now in a point where there are 75 different instance types across 9 different families. The families representing the sort of major class, and then the instance types representing the different sizes. There's 21 Amazon-produced images for Windows, different versions of Windows. And there are 13,000 images produced by the community for Windows workloads. And that's supplemented then with 700 or so Windows listings in AWS Marketplace from ISVs. So this is a really vibrant, really large, and really quickly growing ecosystem. So when we move Windows workloads to AWS, the benefits are that we get the reliability, security, flexibility, and cost of AWS, while we maintain the familiar environment that we work in. So we don't need to have a jarring transition from our current state to the new state, but yet we get to gain all the benefits that AWS has to offer. We also have a lot of license flexibility when we bring Windows workloads to AWS. So the simplest model is that you license the software from AWS. This is available for SQL Server. It's available for Windows. Essentially enables you to pay by the hour for the software license built into the cost of running that instance. Or you can bring your own licenses to AWS, and there are two options here. For Windows, the only option there is to run dedicated hosts, which enable you to run essentially on bare metal. For other applications from Microsoft, such as SQL Server, Exchange, the more application suite products, you can take that dedicated option I described earlier, or you can also actually do default tenancy, the normal AWS tenancy, with license mobility. So if you have license mobility, which is a part of software assurance, then you can bring those licenses over to AWS and not have to work in the dedicated host model. So let's look now at infrastructure as a service Windows workloads. So what we mean here are those workloads that look and feel a little more traditional, not quite cloud native, but you're going to see how we're going to adopt major parts of the cloud as part of these transformations. Starting with SQL Server. SQL Server has two options for deployment on AWS. One option called AWS RDS. RDS stands for Relational Database Service. And the other option being running your own SQL Server instance on EC2. On RDS, you get a fully managed relational database. It's still SQL Server. It behaves like SQL Server, but the overhead of deploying, managing, monitoring, and failover all become taken care of automatically. There are some restrictions about the versions of SQL Server that we can support there, and in RDS, the only license model supported today is where you purchase the license from AWS built into the hourly fee. In the EC2 hosted model, you can actually install SQL Server on an instance yourself, and you can control all the settings. This is a normal install of SQL Server. And in this model, depending on exactly how you approach it, you can actually either use license mobility or buy licenses from AWS and built into the image. So for sort of a more concrete example here, you can see on the left side the features that RDS takes care of automatically, and on the right side what you'd have to do for self-managed EC2. So in either case, power, air conditioning, OS are taken care of, but in RDS we go much further. The entire OS, all the database patching, backups, HA scaling. Now let's look at a traditional Windows workload in AWS. A lot of times it consists of these kind of few components, right? The Windows Server, IIS, SQL Server, some kind of file server, often cases, and Active Directory. These are probably the fundamental building blocks. And what I'd like to show you is the options for those building blocks as you move them to the cloud. So in the direct mapping, if we did nothing, we would essentially move all of those components onto EC2. That's the second line you see on your slide labeled migrate. One line below that, as we talk about modernization, we could take the low-hanging fruit, such as Active Directory, the file servers, and SQL Server, and move them to the equivalent AWS services. So for SQL Server, we would move it to RDS. And so our application still experiences SQL Server in every way, but we took the management burden out. For static files in CDN, we could move to S3 to host the files and CloudFront to serve them at the edge. And for Active Directory, we could move to the Amazon-provided directory service, which again is actually Active Directory, but wrapped up in a management layer, enabling us to not be concerned with how to manage Active Directory. Or we can go one step further and actually future-proof these applications and move to Lambda for the compute and for the web layer. And so I'm going to talk more about the story on Lambda later in the presentation, but that would be taking our applications and making them event-driven and not paying for idle capacity. And we could move databases to DynamoDB or Aurora if we wanted to replace SQL Server with modern equivalents. And we could obviously continue to use S3 and CloudFront And then if we get to this final sort of nirvana state, there is no Active Directory because there are no servers. Changing gears slightly to the development workflow for .NET applications on AWS. What we're trying to illustrate here is integration with TFS and VSTS. Developers continue to build applications in Visual Studio. They continue to commit those to TFS. And we continue to use VSTS to build them and deploy them. The difference is that we're going to leverage some AWS tooling, specifically S3 to store our builds, and code deploy to push those builds onto our instances. And then CloudWatch to monitor the health of our instances. In this model, the developer experience doesn't change at all, but we're able to deploy our applications very rapidly and very easily and leverage AWS to take care of the deployment details. So that's a great transition into this kind of CI/CD conversation for .NET. What we're showing here is on the left side of your screen the AWS toolkit for Visual Studio. So this is a plugin for Visual Studio that exposes some of the most common developer-related AWS services right in Visual Studio. So Amazon has taken great care to make that experience feel right at home inside the IDE that you're already used to working with. And here we see how we can do integrations with VSTS. There are a number of options for how we integrate VSTS with AWS. There are some built-in plugins that we can use that will let us do some simple tasks. And as we get more complicated, we can actually deploy VSTS agents onto EC2 instances, and we can empower those EC2 instances with roles that enable them to take actions in our environment. And so in that model, we get the full power of the full AWS API and the command line to accomplish our goals. The sample you're seeing on your screen now is actually a code deploy sample. So we're showing how we could then take our build result and instruct code deploy on how to install this application on our instance. This takes care of copying files, running scripts, and all the sort of work you would have to do to get an application from a built binary to running on an instance. And finally, here's actually code deploy in action. You can see the events that are occurring, what events are coming up, the status and feedback and log messages from each event. And so there's a whole life cycle here to go from starting a deployment to a successful deployment that could target one instance or it could target a number of instances. And here's sort of the overview screen showing you the entire deployment, the instances that were affected, and the state. So again, these tools integrate with VSTS and with TFS, and so we can trigger them on commit. And we can do real continuous delivery so that when developers commit code, that code is promoted through the appropriate stages into dev, staging, and eventually production. And all of that is driven by what happens in source control. And these other UIs I'm showing you from AWS are really just additional UIs to see the progress of those deployments. But they're kind of secondary to the core workflow, which takes place in source control and is very familiar. So I want to take you through a use case for one of our financial services customers where we've deployed everything I've kind of talked about. This is one of the leading providers of tax prep software for consumer tax returns in the United States. And they had aging hardware on-prem and estimated that it would cost millions of dollars to buy new equipment to replace their aging hardware. To make that even more complicated, because it's tax return business, it's very seasonal, right? There's a lot of activity in the beginning of the year through April, then a lot of quiet over the summer, and some more activity leading up through October, and then quiet again till the new year. And so that spiky workload is a very compelling cloud use case because you just consume what you need to consume at the time of year that you need to consume it. So we leveraged all the services that I've talked about over the past few slides and built a series of pipelines that natively integrate and they take the .NET code from our customer and they deploy it to instances, and maintaining the full life cycle that makes sense for that customer and utilizing everything that's familiar in VSTS to do it. The net result is that we migrated 90 applications in less than 90 days, because once we've got these pipelines figured out for this customer, it's pretty easy to onboard more and more applications. So now we can deploy and redeploy all 150 applications into 4 to 6 different environments in minutes. Prior to this project, it would be 8.5 hours for the average release window. We now also have 100% automation, so there are no human steps involved in these critical deployments. That reduces errors and brings consistency, especially as you promote through the stages. And now I'll tell you sort of the net result here. We now have consistent, automated, scalable, repeatable deployments. We have developers that don't need to worry about how the code is deployed. They just produce good code and commit it to the right place. And all these tools can be integrated together with the community tools you're familiar with. So whether it's Visual Studio or GitLab or GitHub or Jenkins or Puppet or Chef, or the innumerable number of tools I could list that are developer tools, there are first-class integrations with all of them to make them work well in the cloud. Now let's talk about modernizing applications. How do we build the next generation of .NET applications in the cloud? We want to leverage the skill sets of our developers who know C#, but we want to be able to deploy new event-driven serverless applications. Or we want to take our existing applications that are microservice-oriented or need to become microservice-oriented and put them in containers to gain more flexibility with how we deploy them. Both of these paths we would consider a form of modernization over the current state. You can see on the left column, serverless. If we go all the way serverless, there's no servers to manage. We're focused on deploying functions that respond to events. Autoscaling is a total non-consideration. It just works. And same with HA. And best of all, we are never paying for idle time because we're not running any servers. In containers, we get to keep a more familiar programming model. We could just take services that we already have and wrap them in Docker containers and deploy them fairly trivially. But the benefit is we get a consistent packaging and distribution mechanism, and we get really, really far along the path to immutable infrastructure so that deploying new infrastructure becomes very simple, and we're never modifying anything in place. So both of these are really great modernization paths. These are the tools in AWS that enable those paths. So the 4 logos you see sort of at the top half of the screen are all about containers. Docker being the underlying technology for all of these. ECS is Amazon's sort of native container service, very full-featured. I'll show you sort of a comparison in a minute. EKS is newer to AWS, but built on a community product called Kubernetes. It's very well adopted in the community. And using EKS, we could take container projects that were built for Kubernetes and deploy them to AWS with no changes. And then Floodgate actually takes it one step further and lets us run containers without running container hosts. So we take away that instance management of having to run hosts that are running the containers. Those hosts are now managed for us by AWS. And then Lambda would be the tool if we're going to go to the serverless model. So if we're going to go and refactor our apps to be event-driven, to be serverless, and to adopt this new programming model, then Lambda is the primary service that powers that. Looking a little deeper at Windows containers in AWS, these are very full-featured. They run on Windows servers based on Microsoft's container integration with Docker. They're fully integrated with AWS as well. All the metrics flow into CloudWatch. Autoscaling works as expected. We get the scheduling engine from ECS. The load balancers are integrated. So this feature set matched exactly that of the Linux containers, but we could do it with Windows containers. So now let's look at the different container options. So on the left column, we're talking about running Docker on Windows standalone. The second column is Docker Enterprise Edition. The third column is Kubernetes do-it-yourself, so launching your own cluster. The fourth column is ECS, which is Amazon's native container management platform. The second to last column is EKS, that open source project that Amazon has built a management layer around. And then the far right column is Floodgate, which deploys containers without managing servers. You can see then for each of those things, there's the hosting model and the support for Windows containers. So the hosting model for the first three are EC2. You launch an instance and you deploy the software and you're off to the races. But you don't get that sort of management layer on top of it. The next three are all based on Amazon products, either ECS or EKS, which gives you that full management layer, not having to worry about installing the software, configuring how it's going to handle failover, all of that kind of detail. And then you can see on the last sort of row, the Windows container support. So today, we have first-class Windows container support in ECS, and we hope we'll see it in the future in EKS and Floodgate. So I would recommend today the starting point for Windows containers in AWS should be ECS. So if that's the container story, here's the Lambda story. Lambda has support for .NET Core. So using .NET Core, you can write Lambda functions in C#. So everything that your engineers know about C# and the language and the libraries they're familiar with, they can use all of that and move towards a Lambda-based model. This would be the most transformative approach to a modernization of a .NET application. So as we move forward to these newer technologies, we can also look at next generation development processes as well. So we talked a lot about the first row. This is a very good option, and probably one of the most highly adopted options to take us from Visual Studio to TFS to VSTS to production. We can also use an Amazon product called Cloud as our IDE. This is actually a web-based IDE that's maturing very rapidly and is pretty capable. We could do our dev there. We could use code commit for source control and code pipeline and code build for automation and deployment. Or we can go the open source route and use any one of a number of IDEs with GitHub or Bitbucket or GitLab as source control and Jenkins as our deployment tool. So all these paths are valid and they're all interchangeable. So we can use what suits our team and our requirements. So we've touched on a lot of these components, but I wanted to come back and show you the actual bits of tooling that Amazon has created. So the AWS Toolkit for Visual Studio is that plugin to the IDE that gives you the visual UI. The AWS tools for PowerShell give you a very native PowerShell-oriented API access to all of AWS. With that, you could build a lot of automations that you need to build yourself. The SDK for .NET enables us to build applications in .NET, whether they're targeting EC2 or containers or Lambda, and access, again, the full breadth of AWS APIs from inside our application. And then finally, as I mentioned, the plugins for VSTS make some of the VSTS tasks for AWS very simple. So at Onica, we think that .NET applications are better served by AWS than any other environment they could deploy to. And to that end, we have a program that focuses on migrating .NET applications onto AWS. It starts with an on-site workshop, followed by a POC that we will build and deploy. This is a quick and effective way to evaluate all this tooling and all these processes that I've showed you and build confidence in your team around the tools, the process, and the capabilities. I've got these links here. They're also in the link section of the webinar. I also want to mention we have another webinar on EKS in particular coming up on the 21st. So if you want to learn more about Kubernetes and Amazon's implementation of EKS, that'll be on the 21st. That link is also available in the links. So now I'll take some questions. If you in the UI there, you can actually post questions, and I'd love to answer a couple if anyone has any. Okay, I've got one here. I'm going to read the question first, and then I'll read the answer. It said, for Windows teams who are new to AWS and maybe even new to DevOps, where do you recommend we get started with implementing all the capabilities you just shared? So my advice here is to actually pick a lightweight, non-mission critical workload and just jump right in. I think you'll be amazed at how much you can learn and how much progress you can make just by diving in. As you hit milestones and wins, propagate those out to your other core workloads. And then, of course, engage experts like us to help accelerate this process. We can come in with that offering I just shared with you and make this a very simple, quick, and efficient process. Other questions? All right, here's another one. One challenge we're having is around tool sprawl. Different teams choosing disparate tools and approaches, each with varying degrees of success. What are your thoughts on Wild West versus standardization? Okay, so I think if we embrace DevOps as a cultural concept, one of the sort of principles would be the freedom to choose. So when we achieve full DevOps nirvana, we want teams that build and run the applications they built. So if we're going to make that mandate to a team, then it usually makes sense to let that team have some flexibility in the tools they're using so that they can choose tools that are the best fit for their applications. That said, there's obviously a lot of value in standardizing tools, the knowledge transfer, the reusability, the cross-pollination. So I don't think the answer is all or nothing. I think there's some guardrails, and then there's also some freedom to operate for teams. So I recommend that you pick a set of common tools that are going to be used everywhere for certain areas of your infrastructure, but that as much as possible you enable freedom beyond that sort of core tooling. I think you'll also find that tools will emerge as a de facto standard as your teams find commonality and what works for them. Someone asked, have you compared AWS to Azure, and why do you choose AWS? So of course we've compared it. The reality is that we're very confident that the pace of innovation at AWS, the pace of growth, the community, and the wind at our backs makes AWS the better target. The reality is that AWS had a significant head start in public cloud, and that head start has carried a lot of momentum with it, including community support, including developer mindshare, including, a lot of these principles of DevOps grew up in the AWS ecosystem. And so we think that AWS is actually the more mature platform over Azure for these workloads, actually, or for any workloads. Okay, I'll give one more second here for any other questions. All right, great. With that said, I thank you all for spending the last half an hour with me, and I hope this was helpful. Feel free to give us some feedback. We'd love to hear from you, and thanks for your time.